lesson is really just kind of combines everything that we've done in Chapter 6 up to this point. It's titled Applying Systems of Linear Equations. And really the biggest thing we're going to do today is you're going to get a system of linear equations that needs to be solved. And instead of me telling you that you have to do it through elimination or through addition or through multiplication or whatever, substitution, you get to look at it and evaluate for yourself the best way or the easiest way it will be to solve that system. So all of the things that we've done up to this point really come into play in this lesson. I think somebody yesterday asked me about one of the equations. Can't we just solve it by substitution because it would be easier? And I said no, because yesterday was all about multiplication. Today you get to make that choice though. So determine the best method to solve a system of equations and then solve it. So when you look at 4x minus 4y equals 8 and negative 8x plus y equals 19, you have choices. I mean, there's several things we can do to solve this. How do you want to go about it, Bryson?
Could you divide the whole top row by 4?
Wow, that is fabulous. Yes, you actually could, because what that would be is actually an extension of the lesson we just did on multiplication, because multiplying by 1/4 is the same as dividing by 4. And so if you multiply this top one by 1/4, you would get x minus y equals 2, right? Shoot, I'm going to even let you do that. Let's just, I'm going to show it as multiplication even though you guys think of it as division, which is fine. So you would have x minus y equals 2. Now we still got choices how we can find our solution, right? We could eliminate here, or we could substitute if you wanted to add y to both sides and find the value for x. I mean, you do it however you want to do it. And so elimination probably would be the easiest, wouldn't it?
Yeah.
So eliminate those two, and then you've got negative 8x plus x is negative 7x. And then 19 plus 2 is 21. So divide by negative 7, and x is negative 3.
I did the elimination. I multiplied the bottom row by 4 and I got the same answer.
Yeah, and that's great. You should, if you multiply this bottom row by 4, so you get negative 32x plus 4y equals 76. Yeah, then you start eliminating, you should get the same thing. And that's the whole point. You know, all of these things, it's because math works. You can get, you can choose your method of solving it and it's going to be okay. So now that we know x is negative 3, go back to this original equation. 4 times negative 3 minus 4y equals 8. So negative 12 minus 4y equals 8. Add 12. Negative 4y equals 20. So y equals negative 5.
Yep.
So the ordered pair, negative 3, negative 5. All right. Next, same thing. We're just going to go through a couple of these examples where you choose your method for solving. What do you want to do here, Carly?
Times 1 by negative 1.
Okay. Yep. We can also just think of that as subtracting one of the equations, right? So if let's just subtract this bottom equation, and so everything in it gets its sign changed. So instead of being when you subtract a negative 2, it's like adding a 2, right? So 5x plus 2x would be 7x. And then we're going to subtract a positive 7y, so the 7y's cancel out. And then subtract 9, so 7x equals negative 7. So x equals negative 1. 5 times negative 1 plus 7y equals 2. So 7y equals 7, which means y equals 1. -1, +1. Okay? All right, what's the best method for solving this one? Joaquin?
Multiply the top equation by 2.
Multiply the top equation by 2 so that our y terms will cancel out, okay? So 6x minus 8y equals -20. That gives us 11x equals -22. So x is -2. Five times -2 plus 8y equals -2. -10 plus 8y equals -2. Add 10, so 8y is 8. Y is 1. Carly?
I did it with the other equation and got same thing with this.
You did, I'm sorry, say that again.
I did it with the other equation and it was easier.
It was way easier.
Yeah, I mean,
You made that substitution with the other equation?
yeah.
Okay. Yeah, that, again, you can substitute in any equation. We could have substituted in this equation. We could substitute in this equation. I mean, we can substitute anywhere we want to. As long as we do the math right, it should always come out correct. So that's just a judgment call. Whichever one looks easiest to you, go for it. I tend to pick the one with the most positives in it is the first thing I look at, so. All right, last example like this, we'll move on to a couple of word problems. What method would you like to use to solve this? Times 2 on the top one. So 10x minus 2y equals 34. 13x equals 39. So x is 3. 3 times 3 plus 2y equals 5. So 9 plus 2y equals 5. 2y equals -4. So y is -2. All right, 3 negative, whoops. Was thinking 2, but wrote a 3. 3 -2 is the ordered pair. All right. A lot of words, but we can get through this. Of the 17 species of penguins, the largest is the emperor penguin. One of the smallest is the Galapagos penguin. The total height of the two penguins, sorry for the typo, penguins. The total height of the two penguins is 169. Let's stop right there. Let's put this sentence into an equation. What would that look like?
X plus y is 169.
Okay, so x plus y equals 169, and that's fine. The only thing we have to do here is make sure that which one is x and which one is y. Emperor's x. Okay, so emperor is x. We'll do this here. Emperor is x, and that makes Galapagos y. Okay, that's fine. We just got to make sure we do we make them equal in both the same equations. Okay, so the emperor penguin is 22 centimeters more than twice the height of the Galapagos penguin. So let's turn this sentence into an equation.
X equals 2y plus 22.
Okay, so x, which is the emperor penguin, is 22 more than twice the height of the other one. So 2y plus 22. All right? Find the height of each penguin. So what method are we going to use to solve this? Substitution. We can substitute 2y plus 22 in for x. So 2y plus 22 plus y equals 169. 3y plus 22 equals 169. So 3y equals 147. Divide by 3, so y is 49.
49.
So the Galapagos penguin average height is about 49 centimeters. And then we can just do x plus 49 equals 169. So the emperor penguin is about 120 centimeters.
Put that in order pair.
It seems like it's kind of weird to put that as an ordered pair, but we've been putting everything as ordered pairs, haven't we? You know, in the book, they don't write this answer as an ordered pair. I don't know that you would really need to write this one as an ordered pair. I wouldn't hurt you if you did it, but we'll just leave it. All right. Jared has volunteered 50 hours and plans to volunteer 3 hours in each coming week. Am I missing something there? Well, that's where it starts. All right. I don't know what he was volunteering doing, but good for him. All right. Casey is a new volunteer who plans to volunteer 5 hours each week. Write and solve a system of equations to find out how long it will be before they have volunteered the same number of hours. So this one's a little different than the last one, I think. When you're talking about total number of hours volunteered for Jared equals the 50 that he's already volunteered plus 3 hours per week, right? And so total number of hours for Casey is going to be what?
5x.
That's it, 5x. She hadn't volunteered any yet, but she's planning on starting and going 5 hours a week. So, what do you want to do to solve this one?
Put in 5x for y.
Yep, substitution again. Y is 5x, so we can just put a 5x right here. It's 5x equals 50 plus 3x. Subtract 3x, so 2x equals 25. No, sorry, 2x equals 50. Just thinking ahead there. 2x equals 50, so x is 25. What is that? Do we really need to solve for y to answer this question?
25 weeks.
The question is just asking how many weeks will it be before they volunteer the same number of hours? So x is weeks, so it'd be 25 weeks. What would we find out if we solved for y?
Hours?
How many hours they had both worked at the end of 25 weeks? Okay? And so if we wanted to solve for y, we could, but really we've answered the question. We don't need to solve for y. That's all we're asked for. All right. I forgot to put an assignment slide. Seems like I've been forgetting to do that lately, but it's I have a 6.5 practice worksheet